Let's use a cook stove and pot to explain the first and second laws of thermodynamics. First law of thermodynamics, or law of conservation of energy. Imagine you're heating water in a pot on the stove. The first law states that energy cannot be created or destroyed, only transferred or converted. In this case, the energy you're providing to the stove, usually in the form of gas, is being converted into heat energy. This heat energy is then transferred to the water in the pot, causing it to heat up and eventually boil. So the first law reminds us that the total energy in the system comprising the stove, pot, and water remains constant. It's just changing forms from gas energy to heat energy. Second law of thermodynamics, law of entropy. As you continue heating the water, you'll notice that it takes time for the water to boil, and it doesn't instantly reach the highest temperature possible. The second law of thermodynamics comes into play here. It states that in any energy transfer or conversion, the total entropy, a measure of disorder or randomness of an isolated system, will always increase. In this context, it means that as the water heats up, its molecules become more chaotic and disordered. Eventually, when the water boils, it releases steam, which disperses energy and increases entropy even more. This law explains why processes tend to move towards a state of greater disorder and randomness, which is why heating water isn't an instant and perfectly efficient process. So, when you're cooking on a stove, you're essentially witnessing the principles of energy conservation and the tendency of systems to become more disordered over time. As described by the first and second laws of thermodynamics, let's explain the efficiency of a cook stove and pot cooking food in terms of the first and second laws of thermodynamics. Efficiency in terms of the first law of thermodynamics. The first law of thermodynamics, also known as the law of conservation of energy, tells us that energy cannot be created or destroyed. It can only change forms. When using a cook stove and pot to cook food, the electrical or gas energy supplied to the stove is converted into heat energy. This heat energy is then transferred to the pot and its contents, food. The efficiency of this process is determined by how effectively the heat energy is transferred to the food. Higher efficiency means more of the supplied energy is converted into useful heat for cooking and less is wasted. Factors that affect efficiency include the quality of the cookware, the design of the stove, and the cooking techniques employed. For example, using a well-insulated pot with a lid can help retain heat and increase efficiency by reducing heat loss to the surroundings. Efficiency in terms of the second law of thermodynamics. The second law of thermodynamics introduces the concept of entropy, which measures the disorder or randomness in a system. In the context of cooking, it means that as you cook food, the energy is not 100% efficient in achieving its desired outcome. Some of the energy is lost as heat dissipates into the surroundings, and some is used to increase the entropy or disorder within the food itself. To maximize the efficiency of cooking, it's important to minimize unnecessary heat loss, e.g., keeping the pot covered, and employ cooking techniques that minimize the increase in entropy within the food. For example, cooking at a lower temperature for a longer time can sometimes be more efficient than cooking at a very high temperature because it can preserve the structure and moisture of the food better. In summary, the efficiency of a cook stove and pot in cooking food is influenced by both the conservation of energy, first law, and the tendency of systems to become more disordered, second law. Maximizing efficiency involves optimizing the transfer of heat to the food while minimizing heat loss and minimizing the increase in entropy within the food itself. Thank you for watching.